just say, okay.
Okay, are we okay to start now? Welcome to the second webinar, SEDA Solar webinar this year. We are going to have a session on designing with solar and how that could be linked with occupant health in buildings. The show is predominantly domestic architecture, but that could also be applied to non-domestic buildings. My name is Filbert Musau. I've been working at MIRU, that's Macintosh Environmental Architecture Research Unit, since 2009. Before that, I worked at the University of Bath for 4 years, and before that, I was in southeast of England studying and practicing architecture for 5 years. And before that, I was in Kenya growing up and in my early education. And we are happy today to have Gokay, one of the forefront architects in sustainable architecture in the UK and globally. And with that, I'm going to turn it over to you, Gokay.
Right, Filbert, thank you. Let me try to first share my contact and screen. Start broadcasting. Okay, and then I will go, oops, I will go to my, everybody asks the question, but can you see it?
Yes, we can see it. Perfect. Thank you.
Thank you. Firstly, thank you, Filbert, giving me a good instruction. And thank you for everybody really sparing the time, having the time to listen to me today. So as Filbert said, I'm going to speak about solar architecture and occupants' health. And research and practice and the lessons learned, and I will share with you today. So I look forward. All the buildings you saw on the screen is probably within the last 25 years. Bottom right, zero heating house, just about 1998, 99, and then goes to the latest on the top left, the Greyhound Bay project. Right, so a bit about myself. Filbert grew up Kenya. I grew up in Cappadocia in Anatolia, some part of the Turkey. Some of them maybe seen it. My father was a teacher. That's my birthplace. The reason that I'm showing you today is all about, the climate and about thermal comfort, that we've actually stayed one of those caves. I don't mean total cave, of course, that, we had the heating and other things, but it was a fantastic place. Winters and summer was a comfortable place and handled the environment well. And I've been in the university for a long time, actually, as long as I'm practicing. And within that 25, 30 years, I haven't given up practice and also carrying on the research, which is quite unusual, really. I always believe theory without practice is empty. I'm sure you have that. And one without the other is blind. I think I'm very lucky to be both worlds. It gives you a kind of sense of ambition and understanding and innovation. More importantly, ability to take risk and also resource. Excuse me. What is a right? There is, of course, clear relationship between the well-being and the built environment, and there includes, without reading, all the factors, but I think we need to understand there is a complex combination here. There's genetics, environment, and factors. The reason I'm saying this is we sometimes built environment professionals try to get a credit for designing well-built and healthy places, but I don't think we have a direct control. However, our design and quality of a home and neighborhood is really important. Not just home, but the neighborhood is the key contributor to health, well-being, and people who live there. But we need to understand it is much complex than that. So I told Colin that I don't read much books, but I was looking at one of the reports recently, and I looked at it and I thought, what, as a built environment person, I don't deal with the physical environment, but measurables and unmeasurables, which is maybe quantitative and qualitative aspects of it, light, daylight, but also aesthetic, color, ease of use, privacy, greenery. So there's so many design metrics to think and deal with that. So today, probably most of my talk will be on the physical environmental bit rather than covering the rest of the complex matrix and how I contributed to the health and well-being rather than really created more like a contribution that I made or I tried to make. Well, you will learn or you will know that, working with climatic conditions instead of against them is a key start. I mean, using sunlight, obviously known for a long time, and bring huge synergies and benefits to the users and the people. But also harnessing the power of the sun to exchange our experience, and obviously minimizing our energy, and which allows us then foster social, environmental, and economical well-being. And they are all had to be worked together. Now, one of the things that actually as a designer you will see later on in my slides, that the best thing that actually is access and dealing and understanding the daylight, natural daylight, and understanding how the passive sustainable principle can be integrated into space. And that will, as I say, to the contribution of the physical well-being of the occupants. Well, I know that you are aware of that, but it is worthwhile to repeat what's this passive solar strategies that the designers can use. Obviously, access to sunlight, but improved vision, wakefulness, sleep, and we discuss a lot about vitamin D and lower blood pressure. I mean, this is actually proven. You can find so many scientific literature about that. So let's put them all together and say, right, it makes feel good. That's why most of us go to holiday, I guess, on the southern first. Now, moving on. Today, I'm going to share my practice-based research projects. I call them practice-based because they are essentially applied research projects. Nevertheless, they always have a research objective. It's not afterthought, but there was a beginning, there was a hypothesis, there was an idea that there was aims and objectives, and then most importantly, those aim and objectives and the performance is being monitored. Obviously, Filbert is the key man here. And all that allowed me to actually learn from it and inform my next design. And the important key here is the iterative process. And one of the claims, or one of the things that people mention about architects, that they move from one job to other, really not understanding or not fully appreciating or learning is another design exercise. I think that's to some extent true. It's getting much better, but now I think the iterative understanding is key to a practice-based research. And obviously, on the other hand, we are going more into the community engagement and participation of our designs. So at this point, I would like to sincerely thank you to Dr. Filbert Musau. He is also a chartered architect in Kenya. And to this contribution, my iterative research and design processes for the last 15 years. It actually lasted in many marriages. So it's an amazing relationship that we both learned from each other. And I think this is what I would like to call also practice-based research project, that there was iterative, there was information I did understand, and Filbert has been key on that thing. Now, moving on to it, obviously, nothing is new under the sun. If one looks at the literature, you will find that Socrates in 400 BC understood for his own house. And you can see the number 345, I think, and the north, south, east, and west. But the kitchen was right at the back, and a living area in the middle, and the front is veranda, if you like. But he did understand winter and summer sun, a lot of winter sun, but the shading, stop overheating in the summer sun. So, and then we move on bigger projects, perhaps the Romans, and make use of the sun and their baths and solaria, starting from the 1st century. But come back to our home, Scotland, and the Black House. I can't really read Gaelic, but it is about back to the wind, face to the sun. So we did know, and we were designing the buildings that actually responding to the climate. Now, my first response to the climate started probably after my graduation and a bit maturing as an architect. The first one, what we called a zero heating home. The Curse to Work from BBC made 2 TV programs early in late 90s, I should say, year 2000, thereabouts. It was me going to Europe, Norway, Sweden, and other countries and wondering why did you use so many insulation? Ours weren't even same standard in Spain. And that learning, I come back home and I was also doing an affordable housing project. So I needed to understand that anything needs to be sustainable, also has to be affordable. This was my first trying a housing, one-off house, which is about £70,000, I think, 4-bedroom or 6-bedroom house. That didn't need a dedicated heating system, but just a wood-burning stove and nothing else. Of course, Kirsten phoned me from Glasgow saying that was impossible in Aberdeen. So came and she had to see in the 2 TV programs. It has been quite impactful, actually. And going back to when people even not speaking about passive house or energy efficiency or nothing like that, there was a house in Aberdeen that actually didn't have no heating. And the first version of triple glazing you can see, but the basic idea, what I was talking about, solar passive gain that I've showed you a couple of slides earlier, well, that's exactly what I was doing. Getting everything to the south, creating a little bit shading through the roof, and then having Velux roof lights, which is also helps the ventilation. About the Velux roof lights, you can see a solar panel. Again, the first version, which I'll come back to later on because you will see how I modified aesthetically the whole thing. So these were the first, I think, also warm cell insulated houses using entirely I-beam technology, 450 millimeter deep. You can see on the top right pictures, the Velux roof light, how deep the timber was. Full of insulation, walls are 350. So with the newspaper insulation, which is about, I think I calculated 6 ton, and it helped actually the heat losses at night, which is something I learned later on. Anyway, that is the sort of, in the beginning of the idea, it was 2 ideas in this. One is, can I make a reduction from 10 kilowatt to say 1 kilowatt heat that through basically triple glazing, massive amount of insulation, maybe a bit of a cold bridging, but at that time it wasn't the main thing. Air tightness was about, I think, 3. So it wasn't a, so to speak, passive house standards. But you know what? 25 years later, I went, it was actually performing as good as passive house standards, and probably with the running cost of £50 or something like that with burning stove. So it's amazing what it could do. So anyway, this was the sort of starting point. And when I said about affordability, I was really interested in affordable running cost. This is particularly true for the social housing, which I will talk about a little bit. So here is a section showing that minimize the north light, maximizing the solar gain, south glazing, triple. Of course, there is an overheating. That's an issue, but I think as understanding it as a designer, I've already incorporated that. With the 4 square meter solar panels, that was helping only, this was for the hot water, by the way, and the massive amount of rigid underfloor insulation. Actually, that was sufficient to get rid of a dedicated central heating system. And obviously, you had the occupants owned by the heat from the kitchen, computer, or other things. That was always sufficient for the whole heat in the house. Then that carried on again. This time, I think somebody in Glasgow Design Awards told me that one of my ex-students, by the way, giving up the architecture, said, he loves my building, but why do they look like a shed? And that was an interesting comment. So after that, iterative process, I've tried to use timber more engineered, more sort of, aesthetically pleasing, if I may use that word, so you can see clear joints and solid. But what I would like to take your, attention to about the Velux roof lights. So there's 2 layers. Top is solar panels, bottom is lights. So first time I phoned the Velux and I said, you have a solar panels in Denmark. Why not in this country? They said, oh, sorry, we can't bring. So after a long discussion, we managed to bring the solar panels of Velux to the in UK. I must say they weren't the best performing, but in terms of aesthetic, it fit well. Compare my first zero heating house, it was just 6 square meter or 4 square meter panel thrown into the roof. I was very desperate to make some, fitting into the glazing system. Moving on, there was another integral truss house which was finished about 2-3 years ago. A research project looking at the truss, basically roof truss applied entire walls, roof, and the floor to saving cost, maximizing insulation, again to the passive house standards, but never gone for the certification because, again, that wasn't the intention. Simplicity and cost saving was the main key. It actually worked wonderful. The Filbert and other colleagues made research on this, both looking at the air quality and some of the other monitoring aspects. Again, just a quick picture. We talked about light and well-being and how, helps feeling sort of relaxed and sun in your face, and everything from really ability to read well to feeling well. It makes a huge difference to a house. The client of this house told me a long time ago, this is again going back to 20 years, that she thinks she's always in holiday. Well, I took the idea then, social housing project, which is these walls are actually 600 millimeter thick, solid walls filled with insulation. This was again very efficient project, one of the lowest heating running costs, but it was a social housing project, again, all to do with minimizing running costs, and so that the tenants can actually spend the money on other items that could be from, looking after or eating a better food. So it is actually health and well-being is critical that we keep the social housing standards very high and use environmentally friendly materials, and everything else that we're talking about has become more critical. The client was then the Scottish Homes, that some of you remember. But I must say, unfortunately, most of the housing associations now subject to horrendous cost restrictions, and all they can do, simple boxes and repeat the same and same. From down to Borders to the Fraser Borough, you will see exactly the same houses. The one that I've hidden a long time, which is actually one of the finalists for Scottish Design Awards, is on the 20, in 3 weeks' time, we should know, at Boxwood in Cairngorms National Park. It's a woodland site, so you can see I lift the whole building off the ground, minimize the impact on the ground, but I suppose we are talking about the solar gain and dealing with the daylight. And the experience inside is actually, it's not my word, but the client, again, telling me that she will never live in a flat roofed room. It does make, obviously, huge difference, understanding of space and the connection to the inside and outside, but generosity and everything else with it. So light and the daylight and the space is absolutely critical and supports each other. And that project is a good example of that. Then this project has been quite important for me because that not just only affordable, but all the elements we are talking about, shading, overheating, daylight, solar gain. How do we become all of them together as a single identity design? I think Model D House was a builder who used to do basically chalets and holiday homes come back to me that he needed new ideas, and because his basic buildings no longer meeting the building standards and the energy efficiency. And he was brave enough to take a risk. I think we've got about 15 number of those built in the country. It was a KTP project, which is technology knowledge transfer, it means project. So it is actually started about an idea of a concept that how do we create houses with double skin that inside could be perhaps a Scottish pine, and then the outside could be perhaps a better quality larch treated if required. So not only about solar, but also protection. But at the same time, if I can go back, it gives you this uniform look, and that the aesthetic becomes a different and how it fits into the rural landscape. I think that was one of the ideas that I felt that something probably 20–30% cheaper than a normal house fitted in well. Now, after all this, then came again after my visit in Denmark, I met a couple of Norwegian and Swedish low energy housing designers, and they were keep talking about passive house, but passive house in a social sense, and they were quite against the German passive house standards, and they were talking about Nordic passive house standards, which was obviously same argument that we are having. We don't really have -20, so why we are designing to this? I mean, what Scotland? If you leave the Cairngorm out, we are talking about 1 to plus or -0. So why do we design that kind of a standard? And as a result, we've done the first passive house. I think is exactly called Tagna Cladach, which is, again, my Gaelic isn't good, is house by the shore. And same housing associations, the white tower that I've shown you, it showed how, creative, innovative people in the housing associations that we had and still have, but how they are being actually slowly grinding down, which is really sad news for me. Anyway, coming back to do this project, Filbert and others involved the whole 2 years POE exercise. And passive house was really challenging because of the houses wasn't looking north and south, but east and west. And as I told you, solar gain is absolutely critical for your calculations. If you don't, then you have to get your specification up to certain standards. But there is always a way out. There's 2 ways of calculating, of course, heating load and the heating demand. And the heating load, easier achieved, in my opinion, in Scotland than in anything else. So we went with that and we just made it with some additional insulation. Again, my idea here wasn't actually, wow, passive house is the only thing way forward. It was about how do I make a huge reduction on the running cost because they are not for sale, and the money can be used other health and well-being activities. It was simple as that. This is where we came. We learned a lot apart from solar gain. We learned a lot mechanical heat recovery, ventilation, and heating systems. Remember, this is the first one, and we all make mistakes. But Filbert always says that I was very brave to expose myself in the design and happy to live with the criticism, which I did, because I think that's the learning process. Nevertheless, it has been a fundamental for the Scottish Passive House and learning, which almost like when I started 2005, this project, now we are coming 25 years later, we are trying to adopt it. So that tells something. Now, of course, social housing is always going to do passive house, but what about the serious guy who does the 90% of our housing and non-architect design most of the time, the mass market, the volume house building market? How do we actually get them to the passive house standards? So that was another research project which I worked with Dandara in Aberdeen. It was a almost 2 years research project funded by the BEST, then it was Construction School Innovation Centre. And the whole idea was, can we roll out the passive house? I mean, that the builders were moaning about the cost and difficulty and many, many other challenges, supply chain and you know, that the skill shortages, I can name it, and the worst case was, of course, that the banks, mortgage companies, and the valuation surveyors not really valuing these houses any better. So why would somebody will buy 50,000 more house when there's the same lookalike house as the just other building regulation standards? So they were the questions this project tried to be addressed. It wasn't just, you know, the power passive house calculations. And the other main thing is, like, the 2050, we're already built 80% of the stock, right? So if we don't do our new houses with that kind of standards, so there's no point really working on it later on. So we will have the same problems, you know, extended. First, we started, this is a difficult project. As you can see, sorry, if you don't mind, I'll just go back to, if you can see on the top right, I've chosen the most difficult house types. I mean, most house types can be square and simple, then the passive house is no problem. But when you have the dormers and the roof junctions like that, and if you can demonstrate on this one that you can, then others becomes an easy. So the first thing, obviously, we want to design is the walls, you know, and decide where the insulation going to go. I mean, the normally passive house walls has to be about 300 and more, but here you are working with a builder, half 140 millimeter, 150 millimeter, half of what you need. So anyway, after looking many, many options and heating load and heating demand, as I say to you, heating load, pouring the insulation, I think 400 millimeter rigid insulation under the floor, we managed that. So that is the how we managed that project. It was give and go, but it was a huge learning curve for both, for us and for the building company. But the truth has to be said, the first one was cost considerably more money. But at the same time, it's shown us that you could repeat that. You need to go back to design. However, my main objective was not redesign their houses. They already had a product. How do we take their product? Because the volume house builder already believes that they've got a marketable project. Last thing, they want the architect coming in and telling them how to design their buildings. So the most important thing is here is the lessons learned. Again, many, many lessons from engineering to valuation, but I'm only going to speak here. Solar gains, orientation, altitude, and location. As I said to you, there's a heat demand or heating load that you can meet. Heating load, in my opinion, is the way forward, but some establishments and some of the people doing the heating demand will look down slightly because it's, you know, easier to get the pacified calculations. As I said to you, we have a lack of solar gain compared with even southern England. So it could be maybe we need to think about our passive house standards, which is, I'll come back to this at the end of my talk and we can discuss. The good thing about that, the orientation does not influence the compliance by heating mode, I think. But if you go for the heat demand, then south becomes critical. If you go on an Excel sheet, you can actually put some figures and look at yourself to that. Now, the next project is Orkney and 6 senior ladies who wanted to live together. It's called Hope Co-housing. I had to make sure that really I understood and the project need to be innovative and exemplary. So it wasn't about putting 6 houses together. First thing I did actually went 5 other professors in the university with, from nursing to health to physio to artificial intelligence, and asked their contribution to the project. And the big idea is, how do we design a social space, which is the most important? 2 reasons. One is to do with, of course, daylight, sun, but the other very important is to do with social aspect of it, social isolation, how these people can help and support each other. And at the same time, they can have their privacy. So that was the key. So I've started actually with a model looking at this front space, which is going to be about 40 meters long. So they can walk, there's a mobility, there's a meeting places, there's front gardens, but all covered, if you like. So I'll give you a computer images here so you can see what I'm talking about. Of course, overheating, we need to stop, but it's basically a single glazed 40 meter long social corridor, which we call it. They still got the front and back doors, and then this space becomes a social space where they can visit and talk, but at the same time, they can keep mobility. Within the houses, of course, we had all the artificial intelligence and other, from understanding through computer algorithms if they're going to fall. There was a pain management, or there were, if they didn't open the, say, fridge 3 days, we would often know. So all that systems we're going to build on it. It is unfortunately still on the, we got the building planning and the building warrant, but still on the funding stage, which is Scottish government hasn't been a little bit, could be a bit more generous, and we could have really learned a lot, because it wasn't just an architectural project, it was more of a many other academics involved with that, and could have been exemplary project. So you can see in a quick plan section, one side of the house is the living quarter, other one is the sort of sleeping, if you like, and the front aspect of it, there's a front garden and there's a corridor aspect of it. But you can come the house entirely from back as well. So if you don't want to involve, or if you're in a miserable mood, you can come out, play, or you don't, you can hide. And then the rooms starts with maybe the kitchen at the front, which is more social space, and then the bedrooms towards the back. So there are some kind of a, you know, semi-private, private, and public spaces. When I did the environmental strategy, you can see daylight, if you read a little bit about promoting positive health. So everything I said is health-being, well-being, if you read it, They are all to do part of the well-being. Actually, this project is about health and well-being. So the point I'm trying to make, actually, we maybe need to rethink about how do we live and what are this kind of co-housing and shared ownership and a community, a different way of design. Why can't we get away from this simple hundreds of boxes and cul-de-sacs designs by, you know, volume house builders shifted to us? Why can't we have some model, at least at 20% as a start, that cycles and keeps people longer in their houses and perhaps could be some help toward the NHS solution? I know that's a different subject, so I won't talk about that, but I'm just showing you that this kind of a house is all about health, well-being, and air, and clean air, energy efficiency. And from there on, I'm moving again to Greyhawk Bay project. Some of you may know or may not. This is on a monument in Aberdeen to the Aberdeen Harbour. It has been most successful project. It's 2 years old, but I think almost 50,000 people visit it. And we are in the second stage. It's called Greyhawk Bay. You can look at it later on if you like. And this is entirely, obviously, self-sufficient. You can see the solar panels at the roof. And so there's a little cafe, but also more important in education about marine life and everything else. So every day there is some kind of an event in it. It's so much that we are now extending the whole thing. Not just the building, but actually we are building other things with it. So that is sort of, I think that SEDA is keen that I talk about this, not as a solo project, but community and co-creation is called, I think, the new fashionable word for that, that maybe I will cover this if they ask me again. Now, I talked to you all about good things. Recently, I've been involved in a very interesting project. I hope you will find it interesting. It's called heat stress, and it's in Kenya, Filbert's town. So, well, we know all heat stress, but it's not something actually we talk a lot about it, although it's 26 degree plus as a heat stress, and it has a huge health and well-being impact. I mean, I will admit that I found this recently, this information. I didn't know, but I haven't designed any project deals with it. And I always talk about how wonderful is the solar gain, passive solar gain, but this is the other side of the coin. Yes, in the northern climate is brilliant, but what happens when you go Africa and other places and low income and the shanty towns? And that's what really is interesting. So this project now I'm going to talk about is, again, critical and interdisciplinary project. I know it's a sort of, what they call, up-to-date, like sustainability is the buzzword, and the interdisciplinary or multidisciplinary or disdisciplinary, it's a bit academic, but you actually, like the co-housing, you need other people to work with the architects. I would say is almost beyond architects. It's just we need to understand that the housing is a complex and we have to work with others. And we had 5 of us from AI, computing to health sciences, and we all applied for a small funding of, I don't know, 50,000, and we've awarded, and we all went to Kenya. Before we Kenya, of course, what we were asking was, what we were all aiming was, as the growing public concern in Kenya and the places, similar locations like that, and global south, informal settlements, and they actually have the highest vulnerability to heat stress. not us. But, how do we actually deal with it? Almost like idea of a retrofit. But to understand that, we needed to do research, and there was an engineering, all the other aspects. And even to guess in 2030, 40, 50, that's where the artificial intelligence comes in. That's what the manipulation of data comes in. So here we go. First Amsterdam and then Nairobi. There was obviously, you can never do this kind of work without having some kind of a connections. From Mobile University, one or two people up there did their PhDs, Aberdeen University, good contacts. And we went to the Nairobi, and then after that, 8 hours drive with a private, you can see on the right hand side, a Jeep or a car that took us there. I mean, I know it was a long journey, but it gave us a really insight of many towns and the landscape you drive. So that was Nairobi 2 there. And the first thing obviously is like, what are we looking at? I mean, I never been in Shantytown before, and they look like all the same. I wouldn't know from my left to right. So we had 2 Kenyan students come along with us, and they've already spoken with the areas and the people, landowners, house owners. So we've selected 6 houses from 50 houses that I had to make decisions, which I'll tell you why. And then 2 for control and 6 houses that we have to install and monitoring equipment, which I will mention in a second. So this is the maps that it shows the areas. And it was and I saw it in TV, but it was a bit of a shock, to be honest with you. But I also amazed that inside the houses was like, they managed to make a home from a thin shed. It was 2 rooms. These are called 10 square meter houses. Basically, the one on the right is the living room. Behind the lady is the bedroom. And they sleep on a net because of the mosquitoes. And there's a front door and side window, both lockable for basically ventilation, and all the other water and toilet facilities are outside. So now we are going to deal with, overheating, and how do we actually what we can do passive rather than solar. This time we're going to keep the solar out or try to help. And I need to set up lots of equipment for the research, the idea we're going to pursue. So I need the external temperature, internal temperature for the occupants wearing a Fitbit. So we will get their body temperature before and after of the installation of geothermal solution, which I'm coming back to in a second. So 6 houses, we've located all of those. And then 2 students coming weekly, taking the handhold temperature. Before and after. Before means like we haven't done as it is. After, you will see in a minute what we're going to do. So geothermal cooling, we thought, is a solution. Was that basically putting some pipes under the ground, because we all know that the temperature under the ground is lower. In Scotland or anywhere else, always in Scotland, for example, between 8 to 12 degrees, and won't change if it's a minus 30 or plus 30. So same in the most of the places. And I wanted to know what is in Kenya and how deep do I need to go. But before then, we need to understand, obviously, as I told you, nothing is new under the sun. A little bit literature review showed me this has been a little bit tried, not a lot, but in India, Delhi, and there was some experimentation, took PVC pipes. So that was a good start. But the next thing I need to know, what is the length? How deep do I need to go? You know, what is the time and velocity and length, so I can understand. So after learning from the literature review and the help with one of my mechanical engineering colleagues, we got the key parameters of depth has to be 1.5 to 2 meter, pipe diameter is 10 centimeter, which let's talk about 100 centimeter. Your usual PVC 100 millimeter pipe length can be up to 10 to 80, which we go for 40. And the velocity. Velocity is a difficult one. How do we create that? So my first job was in the digging a hole and then finding out the temperature underground. So I did this about my height, say 1 point, slightly less, 1.5 meter, gone down. This is all happening in university garden. It doesn't matter really. I'm just looking at the ground temperature, underground temperature. So, and I find one night I've done is about 9 to 10 degree differences. So from 35 is coming to 25. And it will stay like this. So you see, the whole idea is bring a 10 degree less into the house. This is the second. Now the people who's going to do that is leaving next week. 2 of my colleagues are going to install about 6 houses and then dig this 1 meter, 1.5 meter holes in each house will get. And then we are measuring the houses without it, and then we will measure when the fresh air is coming in. But when I was there, I thought, well, this research isn't really 100% is going to be successful because there are other issues that we haven't, and that was the solar gain. Of course, when I touched the roof, inside of the houses, I almost burned my finger on the roof. But on the walls, it was okay because as you can see it, they had this 400 millimeter overhang for the rain, but also sheeting. So that then I asked myself, right, how do I actually stop the solar gain on the roof? Because that could make a huge difference. Then I find out this product. Actually, there's a fire on a pan. This is a cork spray paint insulation. There's 2 pieces of ice. And one, on the right-hand side, the ice turns to obviously water, but on the left-hand side, it's actually resisting it. So I think we need a combination of this. It's easy to apply to the existing roof. That might be a solution in the future for our own designs, but I'm showing you, I mean, that was a little video, but I've just made it a short one for you. So this cork spray paint externally, perhaps it could be very effective. And then we can also have the geothermal and then other learning from the, you know, the body temperature and then we could develop that further. So that is really my Kenyan adventure, and I thought that's a great project to share with yourselves. So the solar gain is not always most welcome. Sometimes it creates serious problems, and it's going to create serious problems. And I was looking actually in here, and the British, UK scenario, and you can see that depending what scenario you believe, I think they're already 1.5. That's going to be established in a year. But 4 degree scenario, including the Scotland, is coming to some kind of temperature problems and overheating problems, which already started. So it might be a serious problem that overheating that we have to deal with that. Now, I think within the given time, almost an hour, is that right? Yeah, I've started 5:30. So I am going to now leave it to my dear friend, Filbert, to come in. And one of the things I've said, I didn't say, but I'll let the Filbert speak about that, because one of the, in my designs, the most problem that I always come across was the people. And then we had this, quotation professor, Catherine Janda, which Filbert will take the board and talk about one or two discussion points. So may I invite Filbert, please, to take over. And thank you very much allowing me to share the projects with you. Thanks.
Thank you, Gokay, for such a rich portfolio of projects. It's interesting to see the diversity of projects from your very early ones to the later ones, where you are actually dealing with two vulnerable communities, one in the global south and one sort of aging group who want to live together. I'll open the floor to everyone or invite everyone for a wrap-up sort of Q&A session, which could double up as a discussion session as well. But I would also like to remind everyone to put any questions into the chat. If you've got any, you can also feel free to answer questions by text on the chat. Gokay, we've got a few questions.
Yeah.
The first one is from Puiwa. With big areas of glass panel, do the houses overcool at night? And there's a comment there about a beautiful design of a social house.
If I understand, with large glazing, is the houses get cooler at night? Is that the question, Filbert?
Yes, whether they overcool at night.
Yeah, I think they would have some time ago, but with the recent advances in triple glazing, including the thermally, the frames, that's 0.7. I mean, that's better than 20 years ago walls. So in a very well insulated house, if there is a thermal mass, I think that will help a lot. But if it's your glazing standards aren't great in double or single, yes, definitely you will lose heat. Like as much as you gain in the cold, you will lose it. But in triple glazing, in Scottish climate, I haven't found that a serious problem, particularly very well insulated houses and airtight houses. But if the whole facade is glass, yes, I think you have to compensate a lot.
Okay, thank you. I could add a little bit of an answer to that. Yeah. About 20 years ago, a gentleman called Nick Baker did some work on the optimum glazing ratio of buildings in the UK, and he divided the country into two climates, one the south, another one cutting across Lancaster and York as a northern climate. And he compared different glazing ratios and came up with a conclusion that between 20 to 30% glazing ratio, if it's well distributed across the facades, you balance light versus the heating energy versus protection for potential overheating from overglazing when you've got heat waves or weather heat shocks. So there is some research that based on building regulation U values at that time, about 20 years ago. Maybe now it's different if you considered today's tighter wall insulation values, which could also mean the heat containment could be higher with the current building regulations. We've got another question from Carmen. Thank you for the question. What about double skin roof approach for external solar shading for the roof area? Has that been considered in your Kenyan research?
I think it could have been considered, but none of these people are house owners. They're all tenants. And as you can see that the building standards or the construction is not really can cope with additional layer. So although the idea is good because through between the two gap, you can let the air in and it will have definitely impact. Yeah, it could be a solution, say, for the new housing schemes, but in the retrofit, the state they are, I think it will be a tricky one to deal with. But for the new future housing, I think, yeah, that's one of the solutions can be.
Okay, thank you. I could add to that as well. I've got, for the benefit of the audience, a similar project, coincidentally, but in Nairobi, not in Western Kenya. Gokay's project is in Kisumu, the third largest city, but in the western part of the country. And mine is in Nairobi. So we found out, just to answer Carmen's question, some of the householders do line the internal of the corrugated iron sheets with insulative gunny bags. This sacks or fabric that is used in canvas type construction or sheds, and they line it in order to protect the solar radiation from coming down into or radiating down into the space. Of course, that is with many other factors considered mosquitoes, because they don't want to open the windows at night when there is mosquito risk. Too much dust during the dry season also is a problem that prevents them from opening the windows. So I think that could be a potential solution, but somebody needs to study that, whether a double sort of skin roof. Again, there's a question of affordability. These are the lowest of the lowest socioeconomic groups, and over 1 billion people in the global south live in these kind of conditions. My project is funded by the British Academy, by the way. So Gokay solution could be a potential solution, that the lining by the occupants and what is proposed here as a double skin. We've got another question. Actually, it's a comment from Andy Woodburn. Thank you, Andy. Nice to see you on the webinar. We worked with Andy Woodburn on project in Queen's Cross Housing Association.
Mm-hmm.
Many thanks for a very interesting presentation. That's a comment from Andy Woodburn. The next question is, Glow, how do you expect a new incoming passive standard in Scotland to impact our buildings? The second point on your discussion slide, I think this is a really interesting question, and it's good to sort of think about how we might approach this. So Gokay, would you like to talk to that?
Yeah, I have, I've been keep quiet, but I've actually done 5 passive house projects since 2010, including social housing, volume builder housing, and 3 one-off projects. And I must say, I have mixed feelings with it. But as I said to you, that is really important that we need to discuss is the buildings uses energy or the people uses? Is this the technical solution that we need to think? Or there is I know you heard that before, other, social and cultural solutions that we need to combine. I think that the pacifier is designed very much of a, now I also must say, I found two types of clients. Whenever I designed the pacifiers for social housing, I had serious concerns and problems. But then you got the informed client who actually runs the pacifiers, which has been successful. But for the social housing projects, they don't even know that they get the project. And there was a question about where was the mechanical ventilation system 2 years later. Or they just bought a B&Q new furniture and they put the whole summer, put the curtains up. Or a teenager never opened his curtains. So all your solar gain calculations and that kind of stuff actually, becomes not used in practice. I think pacifiers obviously has now a massive followers, and everybody thinks doing a one big course and they can just go and design pacifiers, which is actually not the case. It's a big learning process. Having said that, Scotland always been very late, but there will be a volume house builders reacting to it. And I am not sure if they are ready in terms of supply chain, in terms of acceptance, banks, mortgages, and all other things, if we can deliver huge number of pacifiers. But perhaps we can rethink about what Scottish pacifiers should be, and just like the Nordic countries that did, and we maybe find out our local solution. Thanks, Wilbur.
Thank you for that. Two more questions. First one is from Trevor Black. In the hot climates, could a double skin roof be used to drive passive stack ventilation to help cool the interiors?
Well, that depends to the wind. It's not as windy as you think. And that's why one of our concerns on this pipe, and we were thinking, how do we actually get the velocity in this? So we were actually buying or thinking a very small solar operated ventilation system or a blower fixed it. So we're going to look both the natural option and that option and try to understand. Actually, on the roof, if you look at closely to my presentation, there's already a 10 millimeter or an inch gap between wall and the roof because of all of the houses are saying that. I don't think there's deliberate. I think most of them to do with, the quality of the bolt, but it doesn't really help. I did measure the temperature of the external walls. Is about 65 on the roof, 65 to 70 degrees. I mean, it's just too much. And when you are inside, but the worst thing is some people are actually cooking inside. So ours wasn't only, the cooling, but also getting rid of the CO2 emissions and the others that they are cooking with the charcoal and other type of materials, which is quite dangerous. So we thought that it could help to that. At night, the people locks their front and windows and doors. I must say, as a communities, they're very strong and relies in each other. You can see it. Almost there's no single houses. They're always in a terrace form, and the kids running in the middle. So there seems to be some kind of, looking after each other element, social element there, I find. Sorry, it doesn't answer the question, but yes, this getting the air between the double skin can be a solution, but I feel that maybe for the next, when they're getting an affordable housing, maybe that's something that we need to do.
Yeah, thank you for that. I think there's also a challenge with the science of passive stack ventilation, because it's a function of temperature difference between the internal and the external. It's also a function of the stack and the difference between the height of the ingress and the outgoing or egress point of the air. So in a lot of the hot climates, that temperature isn't the temperature difference isn't significant enough to drive the stack because the external temperature most of the time when you want the ventilation is actually higher than what's internal. So unlike here during the cold season and the mid-season where your internal temperature is higher than the external, then driving stack, the science works. But in summertime, when the internal and the external temperatures are pretty close to the same level, then the stack effect is quite weak as a driving force. Next question is from Puiwa. Do you give training to occupants after building passive house for them?
Yes, definitely. I mean, that is actually the most important aspect. As I said to you, there's two types of clients. Ones that comes to you and ask for a passive house, which they've already got a good idea, and going over with them the ventilation systems and all that, heating system, backup heating system, I should say, is meaningful. But when there's a social housing, sometimes every 3 months, tenants changes, or there's a movement, or, I mean, I've done a project in Fraserburgh. We weren't allowed to go some houses. And some houses changed every 3 months. So I don't think that, obviously, the council is supposed to be through their housing department, giving the handouts and letting these people know. But we saw the same problems in Glasgow, as you know. Some of the passive house ventilation systems has been put outside, so the workmen can come and change from outside because of the access problems. So it's a difficult one. This is why I've said that Catherine Junda's saying is really critical, that we can design as much as passive houses we want, unless that the tenants and the occupants understands and cooperates with it, we will be successful. We can't, it's very difficult to impose things onto them. But it was much worse. I think it's getting better. But for me, the main thing is the financial. They need to understand and appreciate that the heating energy costs money, and that will help a lot.
Okay, thank you for that. That's the last question. No, there's can see one more from Janice. Janice, thanks for the question. You mentioned clients commenting positively on high ceilings in houses you have designed.
Yeah. And
commented the need for to rethink how we live. Can you explain more about this?
I think one of the also, yeah, okay, high ceiling. I think that this is usually not necessarily my house design, but the one that I've done, the Hope co-housing, where the money is critical and the rooms are small. One of the old tricks, Janice, that we used to do is opening the roof space and bringing in light. And that has, of course, psychological effect of making the rooms much bigger. Color and the other things will help. But people, UK normally in social housing or other type of housing, get 2.4 meter ceiling, which is actually nothing to do with design size of a plasterboard. That's where the heights comes from. But if you're living in a traditional houses, you will find 3 meter, 2.7. There is a generosity in there. So I would argue that actually that was in our DNA and is changed with the modern building construction. And her point is about opening up the roof. I think light, daylight, and the sun, and understanding the changing season everything else helps to people's, engagement with nature, engagement with sun, and everything else. I think this is what she was saying, that she wouldn't go back to a standard flat roof room because that she didn't know any other better experience. And then it's her saying rather than mine, really. But in the small spaces, it's a trick that I always use because it brings generosity, it brings light, and and if you can incorporate a roof light, then, this is all Velux roof light is about. That's how they sell their product. They're not flat roofed, they're always pitch roofed, and the light comes in because it's critical. Thank you.
Thank you for that. That looks like our final question. Does anyone else have any contributions to make or commentary? If you do, please raise up your hand.
There's one, I think.
There's, one has come in. This might be a dumb question.
It's okay.
But are passive house standards something that we should be striving to achieve in a hot climate? I'm fully on board with passive solar design, but are the passive house standards something we should be aiming for?
Actually, hot climate, passive house, think of a fridge. It could be very, very actually welcome in a hot climate because you can keep the heat out, providing you have to minimize the passive solar gain. So that you have to put your windows on the north or use massive overhangs to do that. Then very much, instead of heating the house, you will be starting cooling the house, some kind of a backup cooling. And that cooling, like a fridge, it will last as long. So I know that for a fact that in some African countries, on some hot climates, passive house, actually a solution is being tried, but both to do with labor and supply and chain and other costs perhaps is limited. But I do know North Africa, there are some, Malaysia, there are some passive house experimentation going on. Yeah, as I said to you, passive house, then we have to, that's why I say we need to rethink about, rather than just taking the designing houses and then trying to get the fighting with the shading in the first place. We need to understand what impact in 2050, 80 these houses will make, and design these houses, maybe minimize the solar gain. But how do you minimize the solar gain and give a wonderful daylighting? That's another solution that needs to be discussed.
Thank you for that. John has added something there. I'm thinking of projects by Francis Carey, like the Gando Primary School Extension, that's in Burkina Faso. John, I could also add something to that. I think passive house has been trialed in conditions similar to hot climates. One of my PhD students 4 or 5 years ago finished. He looked at passive house dwellings in California, which can get really, really hot, and another one in Mexico. Mexico is high altitude in terms of the elevation above sea level. And the key thing is that passive house is about achieving, it's founded on energy or reducing energy consumption. So the 150 or 15 kilowatt hours per square meter per year could be either cooling or heating, depending on where the building is located. So heat protection from a hot climate context is what would make passive house a suitable solution, or potentially suitable solution for hotter climates, if it's about protecting the internal from heat gains through the insulation and shading. Thank you. there seems to be no other question. There is a comment there. There is a thank you text from Glow. Despite my best efforts, I missed much of the talk as I was on course and couldn't get back in time. Could you share the slides PDF with us, please?
Of course. In fact, I've already, I think we recorded this, so you should be able to see the all. And Magdalene has the slides as well, so she'll be able to help you. You're welcome.
Okay, and on that note, I think we are going to have to draw this solar and health Tuesday to a close, Tuesday evening to a close. Thank you so much, Gokay. Thank you everyone for coming. A huge thank you to the solar events team and the SEDA solar committee as well. I think this is a sort of first step to more solar and health conversation in future. So keep an eye on SEDA solar events, and we could carry on with the conversation in another event in future. Thank you everybody, and bye for now.
Thank you very much.
Yes, thank you everybody.
Thank you.
Gokay and Filbert in particular.
Thank you for sparing the time.
Thanks everyone. Thank you. Bye.